To look at an exam question on IV graphs. Pause the video now and try both parts of the question. So which one of these represents an LDR in the dark? So in the dark, what happens to the LDR? So the LDR has an increased resistance, which means that we can work out which one of these lines represents a higher resistance. So we need to know our definition of resistance, which is, V over I equals resistance. So for a given value of current, which one has the highest potential difference? Well, we can see that is line 2. So line 2 has a higher resistance, which means it is the LDR in the dark. Line 1 has a lower resistance, so that's going to be the LDR in the light. How can you decide which graph is related to a lamp and which is a thermistor? So for a lamp, as it's used, as it's turned on, what happens? The resistance increases, okay, because the wire gets hot, and as it gets hot, the resistance goes up. There's going to be more collision between the electrons and the metal ions, which are vibrating with much more energy now that it's hot, and so the resistance goes up. So again, we can use our definition of resistance. Resistance is potential difference divided by current, and think which one of these has a higher resistance. So which one of these has the voltage, the potential difference going up and up and up, but the current not increasing, which means this fraction gets bigger? Well, that is clearly graph 2. So we could say something like graph 2 shows the resistance increasing because for a value of I, a given value of I here, the potential difference keeps on increasing, the current is not, which means that graph 1, this one must be the thermistor. So what do we know about a thermistor? So a thermistor, as it's used, the resistance tends to decrease. So what happens? As current flows through it, the temperature increases, but because it's a thermistor, that means that the resistance goes down, because a thermistor is a special component where, as the temperature increases, the resistance decreases. And here we can see that for a value of potential difference here, the potential difference is not increasing, but the current is increasing. So this fraction is getting smaller and the resistance is going down. Part B of this question is here. Pause the video now and try part B. So quite a simple question. How can we take sufficient readings to plot an IV graph? So we would say something like record the current and the voltage when the variable resistor is set to its minimum resistance. We would say increase its resistance and record the new current and potential difference. We could say repeat, 5 times, 10 times, however many times you think is appropriate, but that's not the full answer. If we look at the IV graphs, we know that we have both positive and negative values for potential difference. So we need to explain how we're going to get that. So we could then say reverse the direction of the power supply. So we're actually going to make this side positive and this side negative, and repeat. And this will give us the other side of our IV graph, this will give us the negative side of the IV graph.